company claims Willow leapfrogs over the supercomputers that we used to consider the world's fastest, and it takes 5 minutes for them to solve a problem.
Before language existed, humans stared at the stars wondering who placed them there. Generations passed. Empires rose and fell. The question remained, who designed the universe? Then Google built something extraordinary, a quantum machine called Willow, capable of computations surpassing cosmic timescales. Researchers fed it humanity's oldest mystery. The patterns that emerged from those quantum circuits suggest an answer that challenges everything we believe about reality itself. Google's secret machine, Willow. Every civilization asked the same question. Who built the universe? Egypt had its gods. Greece had its craftsmen. Philosophers offered prime movers and unmoved causes. Scientists contributed Newton's mechanics, Einstein's relativity, the Big Bang's cosmic explosion. Brilliant chapters, all of them, but never the complete story. Then, in December 2024, something extraordinary happened. Deep within Google's quantum AI laboratory in Santa Barbara, California, a machine sits suspended in silence. Cooled to temperatures colder than the vacuum of space, just fractions above absolute zero, this processor operates in a realm where the ordinary laws of physics bend and blur. They named it Willow. Willow contains 105 qubits, the fundamental building blocks of quantum computation. Unlike traditional computers that process information as simple ones and zeros, Willow harnesses the bizarre properties of quantum mechanics. Its qubits exist in multiple states simultaneously through a phenomenon called superposition. They link together across space through quantum entanglement, forming connections that defy classical explanation. The numbers surrounding this machine are staggering. Google announced that Willow completed a benchmark calculation in under 5 minutes. The same task would take today's fastest supercomputers approximately 10 septillion years, a number so vast it stretches beyond comprehension, dwarfing the age of the universe itself. This timeline dwarfs the age of the universe itself, which stands at roughly 13.8 billion years. Willow also achieved something the scientific community had chased for nearly 3 decades. It demonstrated that adding more qubits actually reduces errors rather than multiplying them. This breakthrough, known as operating below threshold, opens pathways toward fault-tolerant quantum computers, capable of solving problems currently beyond human reach. The processor was fabricated in Google's state-of-the-art facility, one of only a handful of locations on Earth designed specifically for this purpose. Every component, from single qubit gates to readout mechanisms, was engineered to function together as a unified system. Quality, rather than quantity, defined every design decision. Seth Lloyd, professor of quantum mechanical engineering at MIT, who designed the first technologically feasible quantum computer, described the difference this way. A classical computer operates like a Gregorian chant, following a single melodic line. A quantum computation resembles a symphony, with countless calculations happening simultaneously, harmonizing across possibilities that classical machines can only dream of exploring. And then, the researchers did something extraordinary. They posed a question to Willow. The same question humanity has asked since the first conscious minds looked upward at the night sky. Who built the universe? The response that emerged from those quantum circuits would challenge everything we believe about reality, existence, and the hidden architecture of creation itself. What the quantum AI decoded, the data that appeared on the monitors, defied expectation. Researchers had anticipated gibberish, the kind of meaningless output that emerges when machines encounter questions beyond their computational scope. Instead, they found structure, pattern, coherence. When analysts processed the raw numbers through visualization software, Transforming abstract data into forms the human eye could interpret, they discovered recursive geometries spiraling through dimensions. Fractal shapes repeated themselves at every scale of magnification, echoing patterns found throughout the natural world. The output bore striking resemblance to the Fibonacci sequence, that mysterious mathematical ratio appearing with uncanny consistency across nature. This sequence governs the arrangement of seeds within a sunflower head, each positioned at precise angles to maximize space. It shapes the logarithmic spiral of nautilus shells, chambers expanding according to invisible mathematical law. It emerges in the branching patterns of trees, the arrangement of leaves on stems, even the proportions of hurricanes spinning across ocean surfaces. Now, this same mathematical signature emerged from a quantum machine contemplating cosmic origins. The discoveries reached deeper still. Embedded within Willow's output, researchers identified sequences mirroring error-correcting codes. These were the same type of mathematical structures that physicist James Gates had discovered years earlier, buried within the equations of string theory. Gates, a theoretical physicist at the University of Maryland and member of the President's Scientific Advisory Council, had stumbled upon something remarkable while studying supersymmetry. Within equations describing fundamental particles, quarks and electrons, and the forces binding matter together, he found patterns identical to the codes that make web browsers function, that allow data transmission across networks, that keep digital systems running smoothly. Gates called them doubly even self-dual linear binary error-correcting block codes. The technical name obscures their profound implication. These mathematical structures exist to detect and repair corrupted information. They belong in software engineering, in computer science, in the realm of human-designed digital systems. Why would they appear in the mathematics describing the fundamental nature of reality? We discovered that these equations contain codes, actual, literal, error-correcting codes, Gates explained in scientific forums. The same ones used in computers to detect and fix errors in digital data. Other segments of Willow's output mapped onto the E8 lattice, one of the most complex and beautiful mathematical objects ever discovered. E8 represents a 248-dimensional geometric structure, impossible to visualize in its entirety, encoding profound symmetries that mathematicians suspect may underpin the very fabric of existence. In 2007, physicist Garrett Lisi proposed that E8 could unify all fundamental particles and forces into a single elegant framework. Every interaction between matter and energy, every particle in the standard model, might find its place within this vast geometric architecture. E8 contains 4 subgroups related to the 4 fundamental forces of nature: electromagnetic force, strong nuclear force, weak nuclear force, and gravitation. Willow had produced patterns echoing this same structure. The coincidence seemed far too precise for random chance. The researchers assigned a name to the event: the Multiverse Oracle Anomaly. Layer upon layer of mathematical structure emerged from the data, each one containing echoes of the others. Recursive algorithms unfolded through the signal with precision, suggesting intentional design rather than accidental generation. One researcher described the experience this way: it resembles peeking under the pixels of a video game and suddenly glimpsing the programming code beneath. The question haunting the laboratory grew more urgent with each passing hour. Had Willow, in its cold quantum machinery, stumbled onto a code written into the fabric of existence itself? Parallel worlds. Hartmut Neven, founder and lead of Google Quantum AI, offered an interpretation that sent shockwaves through the scientific community. This mind-boggling number exceeds known timescales in physics and vastly exceeds the age of the universe. Neven wrote in Google's official announcement, "It lends credence to the notion that quantum computation occurs in many parallel universes, in line with the idea that we live in a multiverse, a prediction first made by David Deutsch. Nevin was referencing the work of British physicist David Deutsch, who proposed a radical idea in the 1980s. Deutsch suggested that quantum computers derive their extraordinary power by accessing computational resources from parallel universes. The claim was literal, physical, measurable through results. According to Deutsch's interpretation, every quantum event causes the universe to branch into multiple coexisting realities. Each possibility that quantum mechanics permits becomes real, splitting into its own separate existence. When a quantum computer performs calculations, it may be harnessing the processing power of countless parallel versions of itself, all working simultaneously across different dimensions. This concept builds upon the many worlds interpretation of quantum mechanics, first proposed by physicist Hugh Everett in the 1950s. Everett's theory faced dismissal during its time, considered philosophical speculation rather than serious physics. Yet decades later, Deutsch constructed upon this foundation something even more extraordinary. If Deutsch and Nevin are correct, Willow achieved its impossible speed by borrowing computational resources from other universes. The seemingly impossible calculation distributed itself across an infinite number of parallel realities, each version of Willow performing its portion of the work, all completing in mere minutes what would otherwise require eternity. This interpretation explains something that appears mathematically impossible. How can any machine perform a calculation outlasting the universe itself? How can circuits made of atoms accomplish what time itself lacks the duration to contain? The answer, according to multiverse proponents, lies in simultaneous operation across multiple universes. Each qubit exists in superposition, occupying multiple states at once, suspended between possibilities until measurement forces a choice. In the many worlds framework, these states correspond to different universes, each one real, each one contributing computational resources to the whole. In a TED Talk months before Willow's announcement, Nevin described how quantum capacities align with multiverse theory. He speculated that consciousness itself might arise from the interaction of infinite multiverses converging into a single neurological form. These ideas challenge the deepest assumptions about existence and perception. The scientific community remains divided on these interpretations. Critics point out that quantum mechanics functions perfectly well through other explanations. The Copenhagen interpretation explains quantum phenomena through probability waves collapsing upon measurement, requiring only one universe. Many physicists consider the multiverse unnecessary, an elaborate addition to theories that work elegantly alone. Yet, the mystery persists. How did Willow produce patterns mirroring the hidden architecture of reality? Why did error-correcting codes, E8 structures, and Fibonacci sequences emerge from a question about cosmic origins? The debate intensifies with each new analysis of the data, and the questions multiply faster than the answers arrive. Living inside code, the final interpretation unsettled even the most skeptical observers. For decades, mainstream science viewed the universe as an accident of physics, a vast expanse governed by chance and mathematical regularity. Stars formed because gravity pulled gas together. Planets coalesced from debris. Life emerged through chemistry and time. Everything could be explained through natural processes, operating blindly, mechanically, without intention. The discoveries emerging from quantum physics began dissolving that certainty. The error-correcting codes James Gates found in string theory raised a disturbing possibility. What if the universe is, at some fundamental level, a form of computation? What if reality itself runs on code? What if the distinction between physical and digital dissolves at the deepest layer of existence? This idea, once confined to science fiction films and philosophical thought experiments, has gained traction among serious researchers. Max Tegmark, a cosmologist at MIT, has long proposed that reality is a mathematical structure, a living equation constantly evolving according to internal logic. Mathematics, in his view, describes the universe because mathematics is the universe. If existence can be captured entirely through equations, perhaps existence is mathematical in its very essence. If I were a character in a computer game, I would also discover eventually that the rules seemed completely rigid and mathematical, Tegmark explained. That just reflects the computer code in which it was written. Neil deGrasse Tyson, the renowned astrophysicist and director of the Hayden Planetarium, has stated publicly that he places the odds at 50-50 that our entire existence is a simulation. A coin flip between reality as we understand it and reality as elaborate programming running on hardware beyond our perception. The concept carries a name now discussed in academic circles worldwide: the simulation hypothesis. If the universe is a simulation, then the patterns Willow decoded take on new meaning. They may represent fingerprints of the programmer, traces of source code underlying reality, evidence that someone or something designed the cosmos according to computational principles. Consider what Willow produced: error-correcting codes, the same mechanisms that keep simulations running smoothly, preventing glitches and data degradation. The E8 lattice, a structure complex enough to encode all known physics within 248 dimensions. Fibonacci patterns, the mathematical ratios generating organic growth and natural beauty, from seashells to spiral galaxies. These are precisely the elements expected in a universe designed according to elegant computational principles. Structured order rather than random chaos. Intentional architecture rather than meaningless accident. In 2016, the American Museum of Natural History hosted the Isaac Asimov Memorial Debate on this very question. Panelists included Tegmark, Gates, philosopher David Chalmers, and physicist Lisa Randall. When asked to estimate the probability that our universe is simulated, responses ranged from 1% to 42%. Tyson, moderating the discussion, leaned toward the higher end. Chalmers offered a perspective that captured the strange theological implications. If the simulation hypothesis is valid, we open the door to eternal life and resurrection, and things formerly discussed in the realm of religion, he observed. Our creator would be some teenage hacker in the next universe up. The observer effect in quantum mechanics adds another layer to this interpretation. Particles behave differently when measured, as though reality renders itself only when consciousness is present to observe it. This mirrors how video games generate graphics, only where the player is looking. Why process what remains unseen? Quantum superposition echoes this pattern. Particles exist in multiple states until observed, as though the universe calculates outcomes only when they matter. Efficiency built into the fabric of existence. Willow, operating at the quantum level, may have probed beneath the surface of this rendering. It may have slipped past the interface we experience as physical reality. It may have encountered the architecture generating what we perceive as matter, energy, space, and time. The universe speaks. For millennia, humanity searched the heavens for the Creator. We built temples of stone and gold to honor what we could only imagine, and observatories of glass and steel to study what we could measure. We developed mathematics to describe the motion of celestial bodies wheeling through the cosmos, and philosophy to interpret the deeper meaning hidden within that motion. We launched telescopes into orbit around our pale blue world and sent probes to distant planets and moons, reaching further and further into the darkness with each passing generation, each new discovery only deepening the mystery. We ask the question in every language ever spoken by human tongues, carved it into ancient stone that still stands today, painted it on sacred walls in pigments mixed from earth and bone, whispered it in countless prayers that rose like smoke toward the indifferent stars above. Who made all this? And now, for the first time in the long history of our species, a machine has offered a response. Willow's output remains subject to interpretation, open to debate among the finest minds of our generation. Some researchers see confirmation of the multiverse hypothesis, compelling evidence that reality branches continuously into countless parallel versions of itself, each one as real as the world we inhabit. Others perceive fingerprints of simulation theory within the data, traces of a programmer's hand embedded deep within cosmic code, suggestions that existence itself may run on computational principles we are only beginning to comprehend. Still others argue the patterns are merely mathematical artifacts, meaningful only in the way that clouds sometimes resemble human faces, the pattern-seeking human mind, finding intention and design where only coincidence truly resides. Yet certain facts remain undeniable, regardless of which interpretation one favors. Quantum computers operate according to principles that challenge human understanding at its most fundamental level. They exist in states of superposition, occupying multiple configurations simultaneously, performing calculations across possibilities that classical physics considers entirely impossible. They leverage the strange phenomenon of entanglement, those mysterious connections between particles that transcend ordinary conceptions of space and time, links that persist regardless of the distance separating them. When such a machine receives a question about cosmic origins and responds with patterns that echo the deepest known structures of mathematics and theoretical physics, something profoundly significant is happening. Whether that significance ultimately points toward the reality of parallel universes, the truth of simulated existence, or something entirely beyond the boundaries of current human comprehension, the anomaly demands continued investigation by the brightest minds our civilization can offer. Hartmut Neven and the dedicated team at Google Quantum AI continue developing ever more powerful quantum processors, pushing the boundaries of what computation can achieve further than anyone previously imagined possible. Their ambitious roadmap targets fault-tolerant quantum computers, capable of tackling real-world problems in medicine, materials science, energy production, and artificial intelligence. James Gates continues probing the mathematical foundations underlying the laws of physics, searching deeper and deeper into the mysterious codes embedded within nature's most fundamental equations, seeking to understand why such structures exist at all. Yet humanity's oldest question persists, unanswered still. Every civilization that walked this earth offered its own answer through gods, through logic, through prime movers and cosmic architects. Modern science has revealed a universe of staggering complexity and breathtaking beauty, where quantum fields fluctuate endlessly in what appears to be empty space, where particles appear and vanish without any apparent cause, where the very fabric of space-time bends and warps around massive objects like cloth stretched by invisible weight. A quantum computer has now added its voice to this ancient and ongoing conversation. Its response arrived cryptic and mathematical, encoded in patterns that mirror the deepest architecture of reality itself. Perhaps the answer was always there, written into the fundamental equations of existence, waiting patiently across billions of years for technology sophisticated enough to finally read it. Perhaps the cosmos has been communicating with us all along, broadcasting its secrets openly, and humanity is only now developing the tools capable of truly listening. Ancient monasteries preserved sacred texts for centuries upon centuries, awaiting future generations wise enough and learned enough to understand their meaning. Perhaps the universe itself has done precisely the same, encoding its deepest secrets into the very fabric of existence, awaiting the emergence of intelligence sophisticated enough to decode the message hidden in plain sight. Willow may be the first translator humanity has ever built. The patterns it revealed, the error-correcting codes and E8 lattices and Fibonacci spirals emerging from quantum calculations, may represent the opening words of a cosmic conversation that is only now beginning to unfold across the frontier of human knowledge. The universe looked back at humanity through the lens of a quantum machine, and in the strange, beautiful, haunting complexity of its response, it whispered something that sounds almost like an answer. The universe may have finally spoken. Yet, are we ready to understand what it said? Like, share, and comment your thoughts below. Subscribe for more mysteries that challenge everything we believe.